Hey guys, welcome to lesson 8.6 where we work with the two-sample t-test. So we're going to be comparing averages from two populations. So here's the first problem. Do 8 a.m. classes cost students sleep? Campus folklore says students with 8 a.m. classes sleep less than everyone else. So they sleep less. A random sample of 32 students with at least one 8 a.m. class averages 6.4 hours of sleep with a sample standard deviation of 1.1. An independent random sample of 35 students with no 8 a.m. classes averages 7 hours of sleep with a standard deviation of 1.2. So the question is, are those two averages statistically significant? So we want to run the 6-step test at the 5% level, and we want to know if the 0.6 hour gap is real. So 36-minute gap. Two population means. We have mu1 is equal to mu2, and our alternate says that the 8 a.m. classes get less sleep than the non-8 a.m. people with classes. Test statistic and conservative degrees of freedom. So here is our formula for the test statistic. Remember, when we're working with a mean, we're going to be using a t-distribution with heavier tails. And the degrees of freedom, the conservative rule for the degrees of freedom, you take the smaller size minus 1. So whichever sample size is smaller, you subtract 1. Now, the two groups have to be randomly selected and come from independent population. So either you have an 8 a.m. class or you don't, right? So it's you're not going to be, they're mutually exclusive in this case. Normal large sample. So both groups have to be greater than or equal to 30, or if you're working with small groups, which are less than 30, then you need to graph the distribution and there needs to be no outliers or obvious skew. So degrees of freedom, the smaller sample size minus 1. Let's work through the steps. So HOHA. So 8 a.m. classes sleep less. So students, the average of, I'll say 8 o'clock is less than the average of not. So I'll say 8. I'll write it this way. Sorry, the null hypothesis is going to be equal to. So the alternative, 8 is less than not. We can also do like 1 and 2. So conditions, random and independent, 32 students, 35 students. I've got independent random sample, says that right here. Both groups are greater than or equal to 30, both samples, so we're good. Test statistic. Now my degrees of freedom, I take the smaller of the two samples, so 32 minus 1, I'll have 31 degrees of freedom. And my test statistic will be t is x1 minus x2, so 6.4 minus 7.0, divided by the square root of standard deviation of the first one squared, 1.1 squared divided by sample size. Sample size of the first one's 32, plus 1.2 quantity squared divided by my second sample is 35. And when I do that, I get negative 2.14. So now let's find the p-value. So if t is negative 2.14, and I have degrees of freedom, I have 32 minus 1, so 31 degrees of freedom. I'm going to go to my t distribution. I will have 31 degrees of freedom. And my alternate hypothesis goes to the left. So to the left of negative 2.14. So that area is 0.0202. So I'm going to go to the left here. So p-value is 0.0202. Conclusion: since 0.0202 is less than alpha of 0.05, reject the null hypothesis. So there is enough evidence to conclude students with 8 a.m. classes get less sleep. Now, since it's an observational study, we can't say that students with 8 a.m. classes, 8 a.m. classes cause students to get less sleep, but there certainly seems to be an association between getting less sleep and 8 a.m. classes. All right, next one. Textbook spending by major. Do STEM and non-STEM majors differ in textbook spending? Independent random sample, 30 STEM majors, 34 non-STEM majors. One averaged 320, the other one averaged 298. No direction is suspected. All right, so HOHA. So we have the average of STEM. We're going to assume it's the average of non-STEM. And we want to know if they differ. So the average of STEM is not equal to the average of non-STEM. Each group is greater than or equal to 30. Yes, we have 30 and 34 independent random samples, so conditions are checked. We want to find the test statistic. So we want to do 320 minus 298 divided by the square root of the standard deviations, 60 squared over 30 plus 70 squared over 34, and that ends up being 1.35. With degrees of freedom, the smaller of the two sample sizes is 30, so 30 minus 1, which is 29. All right, so 29 degrees of freedom, and we said 1.35, but it's in two directions, so outside of a region. So to the left of negative 1.35 and to the right of 1.35, 1875. So to the left and to the right, so 1.35. So p-value is 0.1875, which is a pretty big p-value compared to 5%. So since 0.1875 is greater than an alpha of 0.05, fail to reject the null hypothesis. All right. So my interpretation here is there's not enough evidence to conclude that there's a difference between the two amounts. So not enough evidence to conclude that there is a difference in the two means. All right, we have one more example. You can check the notes if you want to go over this one. A couple of things to remember. Two sample t-test. So we're doing the 6 steps with a null hypothesis of mu1 is equal to mu2, and then depending on the alternate hypothesis, going left or right. Conservative degrees of freedom is the smaller sample size, -1, and samples need to be independent and random. So the two sample t-test standardizes the gap between two sample means, with each group contributing its own standard deviation by n. Nothing is pooled. By hand, the p-value uses the conservative degrees of freedom, smaller sample size -1. In the first situation, the small p-value was enough to reject. In the second situation, the big p-value was not enough evidence to reject. And this closes out our 4 tests. We had the 1 proportion z-test, 1 sample t-test, 2 proportion z-test, 2 sample t-test, and we've got 2 more lessons on the chi-squared test for independence. But yeah, this is 8.6. Make sure you practice using the formula, and yeah, we'll go to chi-squared next.